For most of human history, a voyage to the moon was the fantasy of the addled brain or foolhardy, for only divine beings and supermen could make the journey. But then humans went aloft on mechanical wings, defying gravity and redefining the realm of possibility. And the moon was within grasp of whoever would build a machine to take them there. But what if we could do something even more daring? What if we could live on the moon? The Lunar Genesis Team is planning to put a base on the moon that will be able to house 1,000 people. The base is called the 14th Colony. It will be built on the rim of Shackleton Crater, which is located on the south pole of Aitken Basin, formed from a meteor that hit 3.6 billion years ago. We chose Shackleton Crater because it has water ice and we have more daytime. The more daytime we have, the warmer it gets. The average moon night is 14 Earth days, which can get to temperatures as low as negative 173 Celsius. The rim of this crater has only 2 Earth days of night per cycle, which will increase the temperature to be much more bearable.
We want the colony to be suitable in resources and economics. Sustainability is important because it is expensive to transport materials to the moon. Our base needs to be able to support itself without a lot of outside import. Helium-3 is an excellent and efficient source of energy and does not produce as many radioactive emissions as similarly powered fuel sources. This will help provide safe and efficient powers to inhabitants of the moon and on the Earth. Our base will provide its inhabitants with a suitable living environment, proper nutrition, and almost all modern necessities. As we want our residents to be comfortable, engaged, productive, and most of all happy. So now we have discussed the goal and our plan on doing it. Let's go into more detail about our base.
The 14th colony will consist of multiple domes, all connected to each other by tube-like passageways. These passageways will be placed above ground because it is easier than trying to put them underground. This will allow people to travel all throughout the base. The center dome will be divided into 3 sections. One section will be the main cafeteria. Another will be a mall-type area where you can buy clothes, spacesuits, and other attire. The third will be an exercise center. On the second floor, there will be a command center. This will give us useful information for running the whole base, such as oxygen concentration and powering quarters. The cafeteria will have a passageway leading to the base's houses, another one leading to the greenhouse.
The frame of the domes will be made out of titanium. We chose this metal because it is the strongest raw metal in the human world, and also because it is available on the moon. For building the domes, we will use a thick layer of ethylene tetrafluorine, ETFE for short. ETFE is a translucent chlorine-based plastic that has many desirable properties like high tensile strength, anti-corrosive properties, and protections from radiation. Using ETFE will help protect the bases from micrometeors, solar flares, and radiation.
Now let's talk about the greenhouse. Here we will grow food using the hydroponic method. Hydroponic growth is growing plants in only water instead of soil. We chose to use the hydroponic method because it increases the crop yield by over 250%. Plus, it will be easier to grow in water rather than earth soil on the moon. There are many problems on the moon that can be bad for the greens, like micrometeors, radiation, and cosmic rays. To solve this, we have put the greenhouse underground. The food we will need to grow are tomatoes, ginger, to help ease motion sickness, sweet and regular potatoes, dense in calories. These crop choices help us meet the nutritional needs of our astronauts while not taking up too much growing space. In addition to the greenhouse, we also have dehydrated vacuum-sealed food that has a long shelf life. These dehydrated foods will include meats, bread, and other foods that the astronauts eat, which will be retrieved from the launch pad.
We want to use available resources at space and moon, so we don't need to import everything. On the moon, resources that are available to us are helium-3, iron, aluminium, titanium, and hydrogen. Helium-3, it is a fuel for nuclear fusion. It is a high-valued resource and can produce energy through nuclear fusion. We can use it as a fuel for our base on the moon. Helium-3 is deposited on the surface of the moon with the effects of the solar wind blowing on the moon. Iron, it is most abundant in lowland minerals. and fairly easy to extract, but it is an essential resource for humans now. Almost every electronic device requires this material, so we wouldn't need super high technique for collecting and extracting this material. But on average, iron is heavier than other materials, so it could cost more energy to carry. We will store the iron in the vacuum of space so that it is not exposed to oxygen or it will be oxidized. Titanium. A substantial amount of titanium is found on the surface of the moon. Like aluminum, we can use it for machines to collect them and refine it. Titanium is a strong metal. People usually mix titanium with other metals to form a stronger alloy. We will use this material to build vehicles like rovers and construct buildings like the greenhouse. Water is a vital resource for humans, and it is easier to make our own rather than import it from Earth. So to get water, we need hydrogen and oxygen. Our plan is to collect rocks from the moon that contain oxidized iron and extract the oxygen out of them to make water. Now, we also have to get hydrogen. We can get hydrogen from space or the moon's surface. Now, with the correct materials, we can start the process.
The 14th colony is a sustainable base that is a new hope for mankind. It will be the first settlement to reach outside of Earth's grasp. Not only this, but it will be mining helium-3 to make extraordinary advancements for the human race. This base can easily sustain 1,000 people or more. If we can put a base on the moon, there is no telling what the future of human development has to hold.